Okay, so next we will discuss about isovolumetric contraction. Okay, isovolumetric contraction in the cardiac cycle. Ventricular depolarization causes the QRS complex on the ECG. Ventricular depolarization causes the QRS complex on the ECG. Ventricular depolarization means the ventricles will constrict, okay, and it will cause the QRS complex. Okay, so as earlier we see that the P wave will form due to atrial systole, then the QRS complex, that this is the Q, the R and the S. Okay, sorry, as this is the P, this, then the Q, the R and the S. This should be in the same line in normal individual. So this will, the QRS complex, the Q, R and S complex, we will see in the isovolumetric contraction in the ventricular depolarization, and triggers excitation, contraction, coupling and myocytes contraction. This will trigger the excitation and contraction coupling, and myocytes contraction. The myocytes in the ventricle, it will contract. The ventricular pressure rises sharply. The ventricular pressure rises sharply. Okay, during the contraction, and the AV valves close. The atrioventricular valve will close. Okay, as soon as this is greater than the atrial pressure, as soon as this is greater than the atrial pressure, as this ventricular pressure is greater than the ventricular pressure, the AV valve will close. Okay, causing the first heart sound. At that time, the first heart sound will heard. Okay, because the mitral valve closes before the tricuspid valve. The mitral valve present between the left atria and the ventricle, and here there is a tricuspid valve. So the mitral valve will close first, so it will produce the first heart sound. Okay, for a short period, as the forces are developing, both the atrioventricular and the semilunar valves are closed for a short period. As the force is developed, the atrioventricular and the semilunar valves both are closed. Okay, as the ventricular pressure is still less than the pulmonary artery and aorta. Why it's there? Because the ventricular pressure is still less than the pulmonary and the aorta, pulmonary artery and the aorta, and no ejection occurs, and the ejection it's not occurs at that time. Okay, this is isovolumetric contraction, and this is called isovolumetric contraction. Okay, so the atrioventricular valves are closed, and it is due to the ventricular pressure is greater than the atrial pressure, but the pulmonary semilunar valves are closed because the pressure in the pulmonary artery and the aorta is higher, okay, than the ventricular pressure. So till that, in this isovolumetric contraction, there is no ejection from the ventricles to the arteries, okay.